ladies and gentlemen. Today we're going to be presenting the third solution, which is for the product to purchase prediction. Our team is called AIQ, with team members Zahir, Alejandro, and myself, Amgad KHALIL, and it's supervised by Mr. Mark Subban. So we will talk about this problem from a graph point of view. And if you think about recommendation systems as a graph, they can be naturally modeled as a bipartite graph into two set of nodes, customers and products. And usually the edges between the products are the customer-product interaction, which in other words is the purchase. So in particular, we're going to talk about light GCN. Light graph convolution network is just a simplified version of NGCF, which is using graph with collaborative filtering that my classmate introduced. And it's an embedding-based model that seeks to find the optimal embeddings of vectors for both users and items. And it also seeks to find the optimal scoring function f, which gives us a numerical value that the higher the value, the more probably that this is a likely edge, which is an interaction between the user and the item. So the way the user item embedding is done in the light GCN is that embeddings are propagated using the normalized diffusion matrix to refine user item relationships. And you start with the initial embeddings, and usually is an iterative process with for usually 2 or 3 layers. Where you retain the next layer by multiplying the diffusion matrix A with the initial layer, and then you repeat 2 or 3 times to get the final embedding. And the diffusion matrix is just nothing but the adjacency matrix of the graph representation, and also the degree matrix of the nodes, multiplied by the embedding matrix, as we said. And the final embedding aggregation is just the sum over all the embeddings of the layers, and it's weighted by a default uniformal alpha k, which is usually 1 over k plus 1, where big K is just the number of layers that we choose for the propagation. It's also based on a matrix factorization, and the point about this model is that it's very simple in the matter that it removes unnecessary complexities like feature transformation and nonlinear activations, and it outperforms neural graph collaborative filtering, as I mentioned, which is where this is only a simplified version of NGCF, and it's also very scalable. That is efficient for large scale recommendation tasks. So the objective goal is that we want to ensure that the scoring function results in a higher value for future positive edges, where the scoring function between a user and a positive should be higher, much higher than the scoring function between the user and a negative. And a negative sample is just a product that the user did not interact with. And the goal is to maximize this objective function, and we then map it. We use a sigmoid function to map it to values between 0 and 1 to get a probability, and using this probability we rank the products. And this introduced the loss that we use, which is a Bayesian personalized ranking loss, and it's just nothing but a negative likelihood of the objective function that we just talked about. And we want to minimize the loss, of course, and then we average it over all the users at the end. So our results so far, note that the model is still training because, as we said, the data set is very huge and it is taking a lot of time. The baseline model that we had, which my classmates introduced about the frequency, the score for it was only 0.33 accuracy, 0.33 at the hit rate at K. And at 60 epochs, we're now at 0.153. But as we can see from the graph, that the loss is going down, and it is training. And hopefully, by the end of the training, because in the actual paper, they did up around 300 epochs on a very much smaller data set. So we assume that we're going to have to do a lot of epochs for this data set because it's huge. And that's it. Thank you so much.
What value do you expect in the end? You say that the best hit rate that you has been obtained with other method is 0.36, so it gives an idea.
No, so the 0.36 was based on also a statistical model that is not a machine learning model.
Yeah, I have understood. So, but you up to now, you are at 0.15.
Yes. So I know that it seems like it's a very small value right now. But the thing is that with this specific approach, it was used in Pinterest with a huge data, and it did a lot of success. So we are assuming that it will. I'm not exactly sure at like what will be the hit rate that we.
Can you risk to give a value?
Can I risk to give a value? I'm hoping that we pass 0.5 at least.
Good. Okay.
Yes.
Just one comment about your question. It turns out that there is a team from Carrefour composed of researchers that are working full time on this task, and they reach 0.39.
Yeah.
Only this. So
we're not exactly sure.
It's a big challenge.
Yeah. It is a very hard challenge. So the assumption of 0.5 is a very optimistic assumption. Yes.
Okay, so you say the model is still training?
Yes.
Okay, so how long does it take?
For this 60 epochs, I think it took 1 day and a half. And yeah, the data is huge and the model is not a very simple model. So I'm not sure if we'll continue for how long, but the competition actually ended, but we're still trying the model because hopefully it's a good approach and hopefully it turns into a really good accuracy at the end.
Okay, thank you. So